Hello everyone, my name is Bhavna and this is OopsRoverOps. So basically OopsRoverOps is an AI orchestrated rover mission control system. So instead of writing a code or manually controlling the rover, a user simply states a mission in plain English. So in this demo, for example, if I say launch mission control and there is a goal to type here. Let's say for example I type navigate to, let's say I choose any of the coordinates. I choose 3 or 4, 3 comma 4 here, and ask it to collect some samples. Like I can ask any kind of samples. Let's say uranium. You can also choose any kind of metal or water or rocks or air quality, anything. Uranium samples, and I will go ahead and start the mission here. So that one single sentence triggers a full autonomous mission pipeline here. So we used line graph to orchestrate multiple agents. So this is not a single prompt. It is a state machine that coordinates independent reasoning units. So here, if you can see on the right side, there is a planner agent powered by GPT-4o Mini through the OpenRouter API that interprets the mission and converts it into a structured plan. So then you can see there is a navigator agent. So the navigator agent thinks through each movement decision. It reasons short horizon. What should I do next to reach the goal? If the LLM fails to reason or produces invalid output, we don't crash here. Every proposed action goes through the third agent, which is our safety agent. So the safety agent enforces boundaries, prevents invalid moves, and can veto decisions. If something is unsafe or impossible, the navigator is forced to think again. For example, we have red blocks here, which are like obstacles. So the mission will abort if there is obstacle in the middle. Here, let's see if it goes back and reaches our base here. So the line graph handles all the straight transitions between the agents. The LLM does the cognitive reasoning, but we own execution and safety with our own hard-coded logic. So while this happens, the front end streams every agent log in real time through WebSockets. You can literally watch the system think, planning, proposing actions, and being corrected, re-reasoning, and adjusting path until it reaches our final destination and returns our base, which is 0, 0 here. So after completion, so this is what generally kind of report. Let me show you. So we have our reporter agent that generates a downloadable PDF version that includes here is a generate report. It says mission successful. So it has mission steps, timestamps, reasoning logs, and final outcome. Let's say there is a downloadable PDF here. If you can see, it shows complete, and this is a report. This is like the basic version of the report. So we also used Docker to create containers, and we used MySQL queries on our code to create tables. So all these mission activity log gets stored in our Docker containers, so we can access whenever we want. Also, we are using Supabase and Vercel to deploy our application. Thank you.